Our planet is a world of interconnected systems. One of the most fascinating and vital is hidden beneath the ocean's surface, the Great Ocean Conveyor Belt. This vast, slow-moving system of ocean currents acts like a giant conveyor belt, transporting heat, nutrients, and oxygen around the globe. Driven by differences in temperature and salinity, this intricate dance of water plays a crucial role in regulating Earth's climate and sustaining marine life. Warm, less salty water from the tropics flows towards the poles, where it cools, becomes denser, and sinks. This cold, dense water then travels along the ocean floor back towards the equator, eventually rising again to complete the cycle. It transports heat from the tropics towards the poles, moderating temperatures and influencing weather patterns worldwide. Without this global heat pump, the poles would be much colder and the tropics even hotter, making our planet a far less hospitable place for life. The driving force behind the Great Ocean Conveyor Belt lies in the fascinating interplay of temperature, salinity, and water density. These three factors work together to create the currents that propel water around the globe. As we know, warm water is less dense than cold water. This difference in density causes warm water to rise and cold water to sink. In the tropics, where the sun's rays are most intense, surface waters are heated, making them less dense. As this warm water flows towards the poles, it gradually cools, becoming denser. Salt water is denser than fresh water. In regions where evaporation is high, like the subtropics, surface waters become saltier and therefore denser. The combined effects of temperature and salinity determine the density of ocean water, driving the vertical movement of water masses. Eventually, in certain regions near the poles, this water becomes dense enough to sink to the ocean floor. The Great Ocean Conveyor Belt embarks on a fascinating journey across the globe, connecting the world's oceans in a continuous loop. In the North Atlantic, near Greenland, cold, salty water sinks to the ocean floor, forming the North Atlantic Deep Water, or NADW. This deep water mass flows southward, traveling along the ocean bottom all the way down to the Southern Ocean that surrounds Antarctica. As the NADW reaches the Southern Ocean, it mixes with other water masses and is deflected eastward. In the Pacific and Indian Oceans, the deep water gradually warms and rises to the surface through a process called upwelling. The now warm surface water then flows westward and southward, eventually returning to the Atlantic Ocean, completing the global circuit of the Great Ocean Conveyor Belt. The Great Ocean Conveyor Belt plays a vital role in Earth's climate system, acting as a giant heat pump that distributes warmth from the tropics towards the poles. This heat transfer has profound impacts on global temperatures, weather patterns, and the overall habitability of our planet. As warm surface currents flow from the tropics towards the poles, they release heat into the atmosphere. This heat transfer helps to moderate temperatures in the higher latitudes, preventing extreme cold and making these regions more hospitable. For example, the Gulf Stream, a warm surface current that is part of the conveyor belt, brings mild temperatures and a temperate climate to Western Europe. The conveyor belt's influence on climate extends far beyond temperature regulation. As warm surface currents evaporate, they release moisture into the atmosphere. This moisture is then transported by winds to other parts of the world where it falls as rain or snow. The Great Ocean Conveyor Belt, this vital system that regulates our planet's climate, is facing a growing threat: climate change. As global temperatures rise, the conveyor belt is experiencing disruptions with far-reaching consequences for our planet. Melting glaciers release vast quantities of fresh water, particularly in the North Atlantic. This disrupts the salinity and density balance, weakening the sinking process and slowing the conveyor belt system. The consequences are significant and far-reaching. The Great Ocean Conveyor Belt, a vital component of our climate system, faces unprecedented threats from human-induced climate change. Protecting this system is crucial for a stable climate and preserving marine ecosystems. Addressing climate change is key to protecting the conveyor belt. Reducing emissions through renewable energy and sustainable practices is essential. Continued research and monitoring are crucial for tracking changes and informing conservation strategies. Protecting the conveyor belt requires a global effort and commitment. By working together, we can ensure the stability of this vital system for future generations. If you liked the video, subscribe to the channel and let us know in the comments below. How do you think changes in the Great Ocean Conveyor Belt will impact our daily lives? Your engagement helps us continue creating informative content about the natural world. By spreading awareness, we can inspire more people to take action in protecting our planet. Thank you for watching, and stay tuned for more fascinating insights into our incredible Earth.